Assalamualaikum warahmatullahi wabarakatuh, and also a very good morning. My name is Hairul from Multimedia University, and currently the Vice President for Research, Industrial Collaborations and Engagement at MMU. So I'd like to first of all thank IRDC of the Future University in Sudan for inviting me to share some thoughts and deliver this talk on the technology transformation approach to become technology society. So this is the plan for today. I'd like to just sort of recap a bit on what is technology, and just to have then a quick view of where we are now. And I think the core of the presentation will be on the two systematic approach, which I mentioned earlier, would be on STEM education and also pushing for transdisciplinary research before I conclude my talk today. So moving on, I'd like to do a bit of a recap on technology, and I think for most of us, probably as the word technology is mentioned, and probably what goes in your mind would be the internet and the electronics that come with it, the gadgets, your mobile phone, of course. Yeah. And what I like to do in this couple of slides is to sort of have a recap that technology has been with us for so many years, moving from one civilization to another. As the buzzword of the fourth industrial revolution we see and hear today, the fact that this is the fourth industrial revolution points to us that there were three other industrial revolutions that had occurred earlier, which was based on steam in industrial revolution, the first industrial revolution, in electricity and computing in the second and the third industrial revolution. But going even further back, you'd see that there has been evidences from archaeological works and excavation illustrating to us that our forefathers, mankind, were at different stages of applying and introducing technology into their daily lives. From the Paleolithic age to the Neolithic age, the Bronze Age, and the Iron Age before modern civilization today. And I think this is very much central to our nature, the fact that we have always been inquisitive, always have this drive to solve problems and challenges. Hence, the phrase necessity is the mother of all innovation or invention. Yeah, and I think what has been found from this archaeological finds prove to us how our forefathers were introducing, sharp stones for purposes of hunting, some for cutting meat, and also agriculture, for example. Yeah. And so this is very much what we mean by technology, and has definitely contributed to past civilizations. Of course, what comes to our mind, as I mentioned earlier, for us living today in this civilization is, the electronics and the pharmaceuticals and so on and so forth. But the fact is, technology has always been around in society. And going not too far back, you will see how the Egyptians, who were very much central to the Nile River. It gets closer to you in Sudan than to me. I've not been to Egypt. And you'll see that there are many technologies being introduced in the Egyptian civilization. And because the River Nile has been very central to the Egyptians, there were technologies like Shaduf, for example. I'm not sure if that's how it's being pronounced, but this particular device was about water lifting or having access to water out of the Nile River for the purpose of irrigation, agriculture, consumption, and so on and so forth. And I think the other technological example that I'd like to mention here is definitely the Sphinx and the pyramid that were built during the Egyptian civilization, which definitely had dependent on technology. It may be simple as we compare to what we have today, but levers and slats on rollers were very much central to the success of building the huge complex of the pyramid and the Sphinx. Yeah, so technology again has been around, was introduced in society to overcome challenges such as building the pyramid. Later on in the 17th century, um, there was this what we call as the Renaissance or the scientific revolution, as the way mankind consumed discovery and science was based on very systematic approach through experimentation, through observation, that later on led to new discoveries. Hence the name scientific method as we know. And this has become the foundation for engineering innovation and practice as well. But I have to mention before, going on later, I'll talk about it, how the Islamic civilization had made huge contribution to science and technology. So in the 17th century, science began to be systematically discovered using, the scientific method approach, and later on, bodies of knowledge were then organized, into so-called the physics, the chemistry, and so on. Yeah, and we know that all this body of knowledge becomes the foundation for modern engineering, and that leads to technology as we know it. Science, which is very different from engineering, has always been for the purpose of discovery, and then later on to reorganize, confirm, and disprove and disseminate statements that describe different aspects of observed phenomenon in physics, in chemistry, in biology, and so on. And as I mentioned earlier, the Islamic civilization was in parallel, if not earlier, contributing to the scientific revolution. As Islam encourages experimentation, exploration, a lot of observation. Yeah, there are verses in the Quran where Allah subhanahu wa ta'ala asks us to think and to observe. And Allah asks us about afala ta'qilun, for example. Yeah, do you not think? Do you not observe? And this was the central motivation for a lot of scholars, which then moved into different parts of the globe, referred to different texts, including the Greeks, and drawn a lot of new knowledge and observation from such works. All this had influenced very significantly to the West, that eventually led to the scientific revolution. A lot of the works, the likes of Ibn Haytham's book on optics, for example, was translated to a lot of text in Latin and English and so on and so forth. So these are just examples of scholarly contributions by Khawarizmi, Al-Batani, Al-Kashi in areas of mathematics, chemistry, in astronomy, in medicine. Ibn Sina is very significant with his work documented in Qanun fi Tib. And moving fast forward to where we are now, just to give you a glimpse of technology as we know it, I did mention to you about the fourth industrial revolution, which is very much on cyber physical systems, a lot of robotics and artificial intelligence. Quantum computing is coming up very strongly now, and this is the basis for the fourth industrial revolution. So in giving you a glimpse of what it is uh, today, technology-wise, there's been a lot of work, sort of looking at trends and technologies coming up in the next couple of years. This particular one has been produced by McKinsey, which is publicly available and for you to also explore. There are works by Gartner, IDC, and so on and so forth. So looking at what McKinsey has sort of studied, looking at different types of technology, they came up with this set of technology across 7 different cross-industry and 3 industry-specific trends. Yeah. So the 7 technology trends you can see. First is very much on industry agnostic trends. This is looking at the next level of process automation, introducing IoT, robots, automation, and so on. Yeah, and there's a lot of work also related to virtual reality, having digital twins. This is an example of how different complex systems are being cloned digitally so that we can do a lot of prediction, planning, resource optimization, and so on and so forth. There's a lot of work also in the connectivity. 5G is about to be deployed globally. Some parts of the world have deployed 5G. In Malaysia, this is some of the focus areas of the country, from university to industry. And on distributed infrastructure, such as the cloud and edge computing, this is also another focus, especially for us in MMU, because we are a wholly owned subsidiary of Telecoms Malaysia. Yeah. And as I mentioned, also the fourth area, next generation computing, because there's now a lot of artificial intelligence applications, yeah, and the need for speedy computation of such focus areas using artificial intelligence, machine learning, deep learning, and so on and so forth. There are some applications which are very time critical. So in other words, you need to analyze in the blink of an eye that relates to healthcare, for example, safety in cars, in driverless cars, and so on. Yeah. And I've mentioned in the fifth area of applied artificial intelligence in computer vision, natural language processing, speech technology. Soon enough, we'll have technology of translation, yeah, from acoustics to text, from acoustics Arabic to acoustics Malay or English. Yeah, so you can actually converse now with somebody who doesn't understand Arabic, and you are speaking Arabic, and he will then depend on a artificial intelligence based translation engine. Yeah, so of course there's work on programming, coding, trust architecture. I may not be able to go deeper into this, as probably they're not into my area. And these are all very cross industry. You'll see that it spans between automation in manufacturing, all the way to language, to healthcare, to telecommunications, and so on and so forth. There are also 3 very industry specific trends that has been identified by McKinsey. For example, here it's mentioned about bio-revolution, yeah, talking about biotechnology, next generation materials, and future of clean technologies. So all this, just looking back at our earlier slides, in the Neolithic age, it would have been, a sharp stone that would function as an axe or a hunting spear. And here is an example of today's technology, and all these have always been pushed into existence because of some necessity. Automation has always been about going for higher yield, efficient operations, cutting down cost, making better quality products at speed, faster speed, and so on. Yeah. So these are the needs that has pushed technology to where it is today. There's a short video on
TM has been at the forefront of every telecommunications technology evolution in Malaysia. Our digital infrastructure, connectivity and solutions will fast forward Malaysia into the Industrial Revolution 4.0 era and beyond. And TM is now 5G ready. We're ready to elevate the quality of life for every Malaysian as we progress to become a digital society, digital economy, and digital government, transforming into a digital nation to make life and business easier for a better Malaysia.
So these are some of the plans being put forth by Telecoms Malaysia in cooperation with the Malaysian government to push for better connectivity, in particular 5G connectivity throughout the country. Now moving on to the I guess the core of our presentation or my talk today, the two essential components that would bring to a technology society, I believe, is to be, the first is STEM education. STEM stands for science, technology, engineering, and math. And the other that I'll be talking about next is very much into transdisciplinary research. So for STEM, I think this has been known many years and known by many parts of the world, in Malaysia, in Europe, in wherever, that STEM education is very central to technology, and how STEM education would then foster a better approach and adoption of Industry 4.0, and coupled with 21st century skills. Yeah, so it's not just the technical knowledge and understanding in STEM, but there's also a very important need to have different skills that is required today, ranging from critical thinking, good teamwork, collaboration, complex communication skills, creativity and innovation, appreciation of STEM in different areas, and efficient problem solving. So these two coupled together will then give birth to a society that's very much having a good sense of creativity, innovation, and leads to better employability. So STEM education, without going into deeper, discussion about STEM education, becomes a very central core to the birth of a scientific society. Yeah. So in Malaysia, for example, this has been the focus, although there's always been challenges in getting more and more of our students to be involved in taking up STEM related courses when they are in the university. What was earlier aimed to be 40% of the school leaving population dropped. As a matter of fact, in Malaysia, I can quote, for example, from 25% to lesser than 20%, but probably it's now around 18%. But these are the challenges. There's got to be concerted effort between universities, the government, non-governmental organizations, NGO, pushing and running a campaign about the importance of STEM education, because we need to get technology going in society. We can't afford to have lesser people involved in science and engineering, and because of that, because STEM is the basis for science and engineering, we will need more and more people to work, not just to do the research, but later on to also implement, engineers to design and maintain technological systems, from robots to connectivity, 5G base stations, and so on and so forth. So STEM education, I think everybody's aware, and I don't want to talk too long into this. What I would like to spend a bit of time is introducing to you this approach of transdisciplinary research. Yeah. This short video is an
We live in a very
featuring
complex
me.
world today. It gets exciting by the day, but with it comes a set of challenges, from education, food supply to climate change. With this thought in mind, we took up this challenge in MMU to foster collaborative research culture. We took this initiative to establish the Digital Futures Research Hub, comprising of 8 different research institutes, each one focusing on challenging areas from education to enterprise, from security to society. And we look forward to work with all our existing partners, new partners, from universities to industry, government agencies, postgraduate students and undergraduate students in this exciting journey with the hope for a better world, a digital world, and we invite all of you to join us, work with us in giving birth to innovative solutions that will address challenges facing today and tomorrow.
So before I introduce to you the Digital Futures Research Hub, I'd like to share with you some thoughts about different terminology being used around. And when we first started, I must confess that I was very ignorant to all these different terminologies, and we had used the word multidisciplinary. But it happens that what we really want is the word transdisciplinary, and I think this diagram would then explain to you, a single field or a single discipline, such as psychology, for example, and how you then have multidisciplinary. They are totally different disciplines, yeah, the likes of architecture and engineering. But when they are not interrelated, yeah, but then when you have interdisciplinary, they tend to overlap. And this is where you'll see there are aspects of architecture leading to effects in psychology, for example, different parts of design and engineering leading to psychological consequences. Yeah, so here hence the word interdisciplinary. And even more important is the word transdisciplinary, which I'd like to talk about today, where we not only talk about the research and development component, but we look at the actual implementation involving practitioners in the workplace, and to see how eventually what is done in research gets translated and be implemented at the workplace involving the practitioners. Yeah. Here's also another description of what is multidisciplinary, interdisciplinary, and eventually transdisciplinary. And with transdisciplinary, the ultimate aim is to solve complex problems, yeah, complex situations, and it involves policy making, it involves management, it involves technology. So technology alone may not be enough to translate into a technology society, but you need also very important aspects of the legal, management, psychology, and so on and so forth. So introducing to you the Digital Futures Research Hub, we established 8 different institutes looking at different aspects of society today, yeah, from cities to society to enterprise all the way to education. So the idea was to have different disciplines within each of the research institute. And what triggered this was, when we were starting to look into THE university impact rankings, yeah, we were looking at how universities are being ranked in terms of how they brought about impact in society. And what was being measured in this ranking was looking at how universities have been contributing to the 17 Sustainable Development Goals introduced by the United Nations. So if you look at each of these different challenges, say for example, SDG number 1, looking at no poverty, um, the kind of complexity involved in solving such a challenge would require transdisciplinary, and I think this very much gave birth to our approach in Digital Futures Research Hub, wanting to have transdisciplinary research. I think the other word I'd like to introduce here is about impact, and you'll see this word being used around research, where ultimately what we would like to see coming out of research is an impactful outcome, and impact would be defined by the ability to generate an outcome through a set of activities. So you then you'd need to sort of work with the end in mind, yeah, to come up with an impactful outcome. And all this relates to the underpinning research, the fundamental knowledge, the basic research that you do, plus engagement with the stakeholders. If you're looking into, I don't know, you're talking about um, water supply, for example, you need to engage with people on the ground. You need to talk to the engineers who work in the water processing plant, for example, and understand the needs and the challenges and the problems that they face, and see what kind of research that you can do, whether you're coming from artificial intelligence, whether you're looking from nanomaterials, or you're looking at psychological management, for example, that eventually would solve this problem, because this problem is very complex, and come up with a very impactful outcome. And when we talk about um, research impact, this theory of change comes to mind, and as I mentioned, you need to work with the end in mind and work backwards. So you need to identify a long-term goal to solve a social problem, work backwards to identify key challenges before you can achieve such a goal, and identify the actions required to address those challenges, and then systematically develop indicators to mark the progress towards the goal. Yeah, so you can have you need that indicator to be as measurable as possible. Yeah, and in order to come up with impact, you need input leading to different activities, leading to an output, and eventually the outcome or the goal that we mentioned earlier. So what was done in our Digital Futures Research Hub? We established this hub consisting of it should be transdisciplinary. So here's the evidence of what I mentioned to you. We use the word multidisciplinary, but what we had in mind was transdisciplinary research. Yeah, so forgive me for my ignorance. So the idea is to foster innovative and cutting-edge transdisciplinary research between undergraduate students, postgraduate students, young scientists, senior professors working together to solve very complex issues and problems. So the idea that the overall framework or the model is within the institutes, you would have key research labs with very high-end facilities, you would have specialists, you would then become a center of excellence and center for reference, and you have consultancy and mentoring being done out of this institute. And all this put together will be servicing the faculties in terms of teaching and supervision. There's also going to be commercial end of it, like consultancies, training, sales of IP, leading to various different outcomes, ranging from spin-off companies, commercial revenue, IP, and so on and so forth. So this transdisciplinary approach, the institute becomes the vehicle to deliver such a model. From a structure point of view, this is how it is being placed, because you then have faculties in parallel. Yeah. So the research parallel to the faculties would be this Digital Futures Research Hub and to different 8 research institutes, as I mentioned earlier. And the framework is, of course, very much dependent on because the research hub focuses on transdisciplinary research, which is very horizontal, putting people in engineering, computer science, psychology, and management together to solve issues in digital education, for example. It will then require support from the faculties having research centers which are very vertical in nature. We have research centers focusing on wireless technology. We have research centers focusing on blockchain. We would have research centers focusing on accountancy and accounting, sorry. So putting these people together would lead to them working together to solve a complex issue, hence the word transdisciplinary research. Of course, from a process point of view, we have the Research Management Center, CIC, to look at the collaboration methods, the IP methods, entrepreneurship development. We have the MMU Press to publish papers coming out of all this work. So when we talk about transdisciplinary research, I think it's best to describe them operating in a program rather than a project. So you can have a program looking at smart urban farming, for example. Yeah, so all this vertical farming. So the program would be led by a professor. In this program, you would have multiple projects. You can have a project focusing on IoT for smart urban farming. You can have another project relating to the behavior of farmers or urban farmers in urban setting. Of course, this whole set of projects are run by lecturers, academics, yeah, supported with funding from various stakeholders. You then have collaboration with other universities as well, especially in areas that you are not capable in. Yeah, there's a need for having good talents from undergraduate students, postgraduate students. Yeah, and all these activities in the program will lead to various outputs, yeah, from publications to IP, knowledge transfer program, consultancy, and commercialization, and I believe with good engagement with the stakeholders, leading to impactful outcome. Here are some of the examples we had in our Digital Society Research Institute, where they were working on solving issues with people of the third age, yeah, health and well-being of the third age, or senior citizens, or in aging society. Yeah, so there were projects relating to entrepreneurial mindset development, There were research projects on developing a Senior Citizens Act, in particular to protect the interest and well-being of aging society. So, this is something that leads to solving some issues in one of the SDGs pertaining to good health. We worked with various universities and the government, in particular the Ministry of Women Affairs, and Family. And all this led to some outcome that would really solve, a problem in society. Here's another example of a program of an integrated geohazard management, looking at landslides in particular. This happened in the Digital Lifestyle Research Institute, in cooperation with Chiba University, with the Malaysian Center for Remote Sensing. They deployed a ground-based SAR, a form of radar, to monitor slopes with very high risk for landslide. So again, this is solving some of the issues mentioned in one of the SDGs, looking at climate action. So I think this is towards the end of my talk today. As a conclusion, coming up with a technology society is not something that can happen in 2 weeks. So as they say, Rome was not built in a day. Changing culture is going to be difficult, but it's something that we have to start. And the two approaches that I mentioned earlier to make this happen is, number one, STEM education, which is very key to establishing a technology society. And my proposal for transdisciplinary research, not just for the sake of having people working together with you, but because of the fact that challenges that we face today are very complex, and it requires the need to have transdisciplinary research that leads to translational outcome, your research into actual implementation, changing society, making society for the better. And with research impact, as I mentioned earlier, we have to start with the end in mind. There's got to be a lot of engagement with society, end users, practitioners, people on the ground to really understand their issues. Of course, us being academics, we are all used to looking at journal papers, but we have to move one step further by engaging with industry, engaging with communities, so that we really understand the challenges and problems on the ground. So I think I'll end here. Thank you so much for listening and to my talk today. As I look forward also to hearing from you soon, to collaborate with you. So you can get in touch with me at my email address, hairul@mmu.edu.my. Thank you so much.